in this example, let's let r of t equal ti plus t squared j. Find n of 1. So that's the unit normal vector evaluated at 1. It's the usual function notation. The parentheses 1 means plug in 1 for t. Okay, anytime you want to find the unit normal vector, there's something you have to find first. You got to find t, right? So let's go about finding t, and then let's see if there's a shortcut to get to n once we find t. So let the formulas be your guide. You know that t of t, you can think of it as r prime divided by the magnitude of r prime, or v divided by the magnitude of v, right? That's of t. I'm just being lazy and leaving off the function notation. So that tells us what to do. What do I have to find first? R prime. So what is that? R prime of t is equal to I plus 2tj. Everybody believe that? Then, okay, here's a trick. We're just looking for n evaluated at a particular value of the parameter, right? Little t equals 1, right? So once you've taken the derivative, you can actually get t evaluated at 1 without finding the function that represents t of t. In other words, what I'm trying to say is, in a very long-winded way, you can plug in 1 right now. And because of the shortcut I'm about to show you, you won't have to deal with functions anymore. You can just deal with numerical vectors. So let's do that. So r prime of 1 is going to be, it doesn't save us that much work here, but it looks a little bit better. Plug in a 1 for t there, you get I plus 2j. Does everybody believe that? Okay, and then what would t of 1 be then? So what do we have to do with r prime of 1? Let's go ahead and find that magnitude. What's the magnitude? Root 5 though, right? Because you got to square that 2. Right? So you take 1 squared plus 2 squared underneath the radical, root 5. And so if you multiply r prime of 1 by 1 over root 5, what do you get for t of 1? So you actually do the scalar multiplication. You get 1, so you multiply this guy by 1 over this guy, right? You get 1 over root 5i plus 2 over root 5j. Does everybody see that? Okay. So now notice the problem doesn't ask us to find t of 1, but if you can find it, then you're in. Finding n won't be tough at all if you can graph this thing. So any questions on how to find t of 1? So here's the shortcut then. Let's graph t of 1. So you could use a chart to graph this thing, or you could just realize that x equals t and y equals t squared if you write down the parametric equation. So what does this thing graph to be? Y equals x squared, right? Happened to be really quick to eliminate the parameter, but you could do it the other way. You could make a 3-column chart, t, x, y, plot points that way if you wanted to. So that's the parabola with vertex 0, 0, right? I'm just going to draw a fairly quick sketch here. There we go. You do kind of need to know how it's parameterized. How would a particle or object travel along this curve if little t represents time? From left to right or right to left? As t increases, wouldn't it have to go this way? If you don't believe that, make that chart. Make that 3-column chart. T, x, and y. I actually made 4 columns, but 3 columns. Make that 3-column chart and start t at a low value or maybe a negative value. Let it increase. You'll see that the points are traced out basically from, it would be counterclockwise or from left to right here, wouldn't it? Now, what would r of 1 be? It would be a point on the curve, right? For the sake of argument, let's say it's right here. R of 1. Now you know what t should look like. T is a unit tangent vector, right? So t should look like this, and it should look like it's 1 unit long. Well, okay, this is 1 unit according to my scaling here, right? This is the usual xy plane. So I'm just eyeballing it, but this vector that I drew, just make it look like it's about 1 unit long based on the scale I've created. Now, isn't that arrow a line segment? So that arrow represents t. Isn't it a line segment, really? What's the slope of that line segment? Well, to get the slope, you would take the rise component over the run component. I'm not actually going to do that, but that's what you would do, right? You would take the rise component over the run component, wouldn't you? I suppose the root 5s would cancel. Well, we're looking for a n, which would be an arrow, a perpendicular line segment, right? You've got 2 choices for n. 2 choices for n. Either n is equal to, okay, if you know the slope of a line, how do you find the slope of a perpendicular line? Negative reciprocal, which means in vector notation, you switch the coordinates. One of them is the opposite of what it was, right? So that leaves you with 2 choices for n. The n that points either this way, too long, or the n that points that way. Both supposed to be perpendicular to t. So let's symbolically, let's write down the 2 choices. So you flip, make it 2 over root 5 I, and one of them's got to be negative, 1 over root 5 j. So this is one choice, right? Or you could put the negative on this one. Make it 2 over root 5 I minus 1 over root 5 j. That's the other choice, isn't it? That doesn't look very good, so let me fix that. Which one does it have to be based on what we've talked about today? It's got to be the first one because that's kind of how the curve is bending upward, right? So n is going to point in the direction that the curve is bending. So n has to be, let me do it in green here. N has to be this guy, not the one that points in the opposite direction. That's got to be n. So if you treat the point 1, 1, which is what you get when you plug 1 into the function, if you treat the point 1, 1 like the origin, think about it. You would go left 2 root 5, up 1 root 5. It would get you, okay, left 2 root 5, presumably on my scale it's that, up 1 root 5, that. It'd get you to the tip of that vector. And so this is the one that makes sense because the first component's negative, that takes you to the left. Okay? So that's it. So n, that's the shortcut. So n is equal to negative 2 root 5 I, oh gosh. We'll get that in editing. Negative 2 root 5 I plus 1 root 5 j. Gotta be. And believe me, in most cases, what we did right there is way easier than finding n using the formulas.